Hi everyone, so I'm back and we are finishing up on ratios and rates. And so we said that slope was a ratio, okay? A comparison between two or more numbers. So here's a question that says, between a pair of points on the line y equals 3 half x or negative 3 half x minus 2, suppose the rise is 9. What would the run be? Now remember that it's rise over run. I actually usually spell it wrong so that I remember the y is in the top over run. And that is our slope. Well, we also know that our slope is equal to negative 3 halves. So you can actually think about it like this. So negative 3 halves, we know that the rise was 9. So what would the run have to be? Well, this is a ratio and this is a ratio, so we want equal ratios. Well, from negative 3 to 9, you're multiplying by 3. And I would be multiplying by 3 in the bottom as well, which would give me 6. However, I also have this negative to contend with, so my ratio would have to be negative. So if the rise I gave you as a positive number, then the negative would be associated with the 6. So the run would be negative 6. So that could mean I'm going up 9, and left 6. Or I could be going down 9 and right 6. That, both will get you to the same point. Okay. But when we're looking at ratios, we always need to check to make sure the units are the same. Because we said that's what made a ratio something you could compare. Units are the same. So let's just review some common units, okay? So we have centimeters to meters, okay? So there's 100 centimeters in every 1 meter. Centi means 100. Milli means 1,000, so there would be 1,000 millimeters in 1 meter. Okay, so if I have 1,000 meters, that would actually mean I have 1 kilometer, okay? A kilometer. And then if I have 1 centimeter, that would be 10 millimeters. And there are some ways to help you remember these conversions, and we can certainly discuss those in class, okay? But let's try and put them to use. So here's how you can look at ratios to compare different figures. So it says find the width to length ratio for each rectangle, then simplify the ratio. So the first thing you have to notice is that they are in different units. So you can't just say these are in the ratio, the length to width is 2 to 4, or width to length. So you have to convert it. So I'm actually going to convert my centimeters to millimeters. I'm going to multiply by 10. So that's going to give me 40 millimeters. All right. Now, the ratio says width to length. So it has to be in that order. So my width is always the shorter of the two. Okay, so that would be 2 to 40 or 2 to 40. And then it says to simplify because you really should always simplify. So it would be in the ratio of 1 to 20. Okay? All right, now let's look at this next one. A telephone pole. I'd like you to change the 7 to a 10. A telephone pole 10 meters tall snaps into 2 during a windstorm. So here I have this figure. It's 10 meters long. It snaps in 2. Okay, and something like that. And it says that the ratio of the two parts is in the ratio of 3 to 2. So we know that this is a ratio of 3 and this is in a ratio of 2. It doesn't mean it is 3 and is 2. It's in a ratio of 3 to 2. So 3 to 2, if we think back to ratios, that is a part-to-part relationship. But 10 is the whole. So that 10 tells me I need a part-to-whole relationship. So there's one way to do this is to think about that idea. So instead of writing it as part-to-part, I can change it to part-to-whole. So I'm going to actually change it to 2 to 5. This would be the part, so the smaller part, and the whole would be 5 because 3 plus 2 is 5. So if I think about that, and I want to get a ratio for 10, 10 is the whole, well, I'm multiplying 5 by 2, so I'd have to multiply 2 by 2, which would give me 4 to 10, okay? So that would tell me that this length is 4 and this length is 6 because they have to add to 10. Now, that number that you multiplied, we've talked about in class already. That's called a ratio multiplier. It's the number you multiply to get a larger ratio, also called, with a figure, I'm going to call it a scale factor, okay? So one way to do this as well is to let x equal that ratio multiplier. And so you could write an equation. You could say 2x plus 3x has to equal 10. And then you'd get 5x equals 10. So x equals 2. So the multiplier is 2. So then this would be 2 times 2, which is 4. And this would be 3 times 2, which is 6. That is another way to do it. It's called an extended ratio, okay? All right, you can use the same idea. Sorry about that. You can use the same idea with a figure like this. The perimeter of an isosceles triangle shown is 56 inches. So I know P equals 56. And let's recall that perimeter means all the sides added up. Now it says it's isosceles. So isosceles means it has 2 congruent sides and they're marked for you. Remember also that those base angles across from those congruent sides are also congruent in an isosceles triangle. Just saying. All right, so it says the ratio of LM to MN, so this side to this side, are in the ratio of 5 to 4. All right, I'm going to use that idea of a ratio multiplier. I'm going to let x equal the ratio multiplier. And so that would make this 5x and this 4x. And since they're congruent, these two sides, that would also be 5x. And we know perimeter means add everything up. So it would be 14x equals 56. So x equals 4. And it wanted the length of the side and the base. So this would be 20, 20, and 16. Okay? All right, the next one, we're comparing more than 2 items, which you can use this idea of a ratio multiplier. So I'd like you to try it on your own, and I'd like you to bring it to class tomorrow. Okay, guys? That's it. Have a great night.